Another use of recursion, a very useful use of recursion, is in backtracking. When we are trying to solve a problem by trial and error, trying all the possibilities and then backtracking for those possibilities that actually did not work out. In order for backtracking to work, we must be able to decompose the problem into a series of steps, which will be try the step, is it working so far? If yes, then move on recursively. If it fails, backtrack, undo the step. You see, the recursive calls have this great property. At each recursive instance, we can remember what step was taken and how to undo it if things did not work out. This is why recursion is a good tool for backtracking. The specific example that we're going to show how to use recursion with backtracking is the maze solver. And this is a bit more complicated example. So we will take it step by step and we will analyze our strategy, we will see demos and so forth. What we want to do is to find a path through a maze by exhaustively trying all the possible routes inside the maze. How are we going to represent the maze? We're going to just use a plain text file with rows and columns where each character in the beginning is either a space, it is an empty space that we can discover whether it leads in a path to the destination, to the exit of the maze, or it is a wall, it is non-space. We are going to assume also that the starting and the ending points are predefined. We know exactly which are the coordinates. And the goal is, as we move through the maze, the paths of the maze, as we discover whether empty spaces leads anywhere, we place an asterisk at any location in the maze that forms a path, at any location that we have already explored. The website that you see on your screen provides us with text files for the maze description, and this is where we're going to get our input for the maze. Here is an example maze file. You can see that the start location is the 1, 0 location, while the end location can be defined in terms of the rows and the columns of the maze. And here is how the solved maze, the path in the solved maze looks like. We have filled in with asterisks. Now we're going to see a few demos of how our code should work so that we understand a little bit better how exactly we're going to fill in these asterisks in the maze and when we should be backtracking. This is the terminal window, and here I am going to show you how our program, our maze solver, should work. As you can see, I am running a program called maze solver that I have already compiled, of course, and I'm providing to that an argument that is the maze5.txt file that you can also find at the topic's resources. When I press enter, you will see the initial maze. You see the first asterisk, which represents where we start from, and you also see the walls that we should avoid and the empty spaces, the paths that we can take. Now, as I will be pressing enter, you can see how the asterisks move, how we explore paths. At this point, we are about to hit a wall, and it is exactly the point where our code should backtrack. The path that we took down did not work out. We need to explore a different path. So you will see right now that it backtracked and it is now exploring a different path. So let's follow the maze and see where it will go. Now it is again ready to hit a wall, find out that there is no point in going that way, so it will have to backtrack again. And it backtracks indeed, and now the maze is solved. We're going to see one more example with a different file. It is a little bit bigger of a maze, but this time it will be automatic. I don't have to press any enter. Pay attention to it and see how the code backtracks and it takes different routes.